This is fantastic. Thanking everyone for joining us today. And oh, there's Warwick. Thank you everyone for joining us. Hey, Warwick, thanks for joining us. Go ahead, man. I wanted to go ahead and turn the floor over to you to make an announcement that you've got going on, something really exciting.
Sure, I just wanted to make all those aware that ASU, in partnership with our project management network and also with the VPPMA, which is a Veterans Project Management Mentoring Association group, we are having an event called the Project Management Summit on September 10th. And I'll put the link in the chat, but we'd love to have participation. It's really an event where we can talk about some of the projects we've worked on in a very kind of safe environment. So the good, the bad, and the ugly. So we'd encourage you all to participate, and I'll again put the link in the chat. So thanks, Timothy.
Sure thing. I had to get myself off of mute. It took me a moment. No, thanks for joining, Warwick. I was really excited when you shared about the summit. I mean, this is something that I don't know. It just sounds to me like the community building that's happening all over the place is really exciting. I'm really excited today to have our speaker Aditya from AWS. Aditya is amazing solutions architect. I've learned a lot from conversations that we've had. Adi, I'm not going to do justice of your background, so I want to give you an opportunity to kind of share and let the folks hear from you directly. But from our perspective and the work that we've been doing around serverless architecture and just discussions that we've had have been really exciting. So ask that you share with everyone kind of your background and really what you're bringing to the conversation today and kick things off. Go ahead and get us started.
Thank you, Timothy. Appreciate it. So I'm assuming everybody's able to hear me? Yeah?
Yes, we can hear
Awesome. Sorry. All right. So like Timothy said, my name is Aditya Challa. You can call me Addy. I'm a solutions architect from AWS. Been in the IT industry for about 15 years. Started as a developer and then grew into a solutions architect. Joined AWS, became passionate with cloud technologies for the last 5 or 6 years, and especially when it comes to analytics and big data. And as you can see, I have 13 AWS certifications. I'm only showing the 9 important ones. So you can see I'm quite passionate about AWS cloud specifically. So today we are here to talk about building and automating a modern serverless data lake on AWS. So before we get started, can we do the polls?
Yep, you want to do all of them right away?
Yep, just before I get started, so I have a good idea.
Here's the first one.
All right, so if you can take the answers, if you can take the poll, so we have a good idea as to where you're all. Okay, coming to about 50-50 there. That's good.
All right, you ready for the next one? Oh, shoot, still voting.
Just give it about 10 more seconds if you don't mind.
No problem. Sorry about that.
No problem.
All right.
Okay. Thank you. Second question, please.
There we go.
All right, there it is. All right, we have most of the votes. So that's good. And the last one. Awesome. Thank you. So we have about 50-50 on the AWS and data lake around, and most of you have heard of the term serverless. So good to know. So for those of you who are not familiar with the terms data lake and serverless, I just briefly got this bit from Wikipedia. So a data lake is basically a centralized repository where you bring all the data from various sources, whether it is different sub-organizations or various departments in a company, mostly in the raw format as it is generated. Bring it all together and store it in one place. And that data can be structured data or unstructured data. It doesn't matter. It could be from relational databases or emails, document PDFs, or even just images and videos, or just JSON data coming from your applications. And sometimes some companies maintain these data lakes on premises, and many companies do it on cloud platforms such as AWS. And we'll talk more about how data lake differs from something like a data warehouse soon. The other term here is serverless. Serverless is a cloud computing execution model where the cloud provider maintains the servers and manages all the allocation of the resources themselves. So instead of the application owner paying for servers, instead pay for service. So which means rather than standing up servers and paying for how many hours these servers are running, whether they're being used or not, they pay by how many times a request has been made, or how much data is being stored, or how much data is being served, things like that. So so if you don't have any usage, you pay very less. If you have usage, you pay based on that usage rather than just based on servers. That's the fundamental difference between a non-serverless environment and a serverless environment. And with that understanding, let's move forward to our main topic today, which is how to build data lakes in a serverless fashion. Now, typical steps of building a data lake. So if you follow this, number one, obviously, since it's a place where we are going to store data, we need to first set up storage. And that storage could be in the cloud or on-prem. It could be a bunch of storage drives that you brought together, or it could be something like Amazon S3, which we will discuss today. The second thing is to bring data from your sources to that data lake. And these sources can be your application logs, they could be sensors, they could be IoT devices, they could be just your customers' mobile applications, where their behavior is being recorded and stored in your data lake. Or it could even be real-time data feeds coming from social media platforms. So all this data is brought in and moved into AWS or into your data lake. And the third step is to cleanse that data, dedupe it. If there's any data that you don't need, get rid of it. If there's any data that you want it in a particular format, or normalize the data so that it has all the similar schema, you do that, you prep it, and you finally catalog that data so that the consumers of that data know exactly what's in that data lake. Otherwise, it'll just be a bunch of bits and pieces which they don't understand. So it's very important that we have a catalog that tells them exactly where is what. Now, the whole purpose of data lake obviously is to democratize access to this data and to avoid silos. So back in the day, we had huge companies with sub-organizations, each maintaining their own data warehouses. One department didn't know exactly what data is being stored by the other department. Sometimes there was duplicates, things like that. This brings everything together. But that means that we have to make sure that there are security and compliance policies that are followed. We can't just give access to all the data to everybody. So we want to configure and enforce any kinds of security and compliance policies on top of this. For example, any PII, any personally identifiable information is identified and tagged so that only people who are supposed to have access to this or to that particular data are able to access that data, or even be able to modify that data or rewrite that data. And finally, make all that available to various analytics platforms or machine learning applications that you might have. So these are the 5 steps involved in a typical data lake, whether you build it on-prem or whether you build it on the cloud. With that basic understanding, now, if you have any questions, please put them in the chat window, or or if you want to speak about those questions, I would recommend that you hold till the end. But if it's something that's brief, you can interrupt me and ask me right away. So with those five steps, or with this basic understanding, let's go to the next step. Now, if we were to define a data lake on AWS, what is it that's involved, right? So if you start from in the diagram that's on the screen, if you start from the bottom, you have all these data sources coming from, whether it's operational databases, ERP databases, CRP database, or it's from devices, web applications, sensors, social media. You bring this data in, and some of that data is going into a data warehouse, and some of that data is going into a data lake. So not necessary that everything has to first go to data lake. And this is a very common misconception that a data lake is a replacement of data warehouse. It's not. They can go hand in hand. And sometimes you can use data warehouse to bring all that data and then store it into a data lake. Or you can first bring it into a data lake and then store into data warehouse. It's all dependent. It all depends upon your use case. But this is probably a good time to understand the fundamental difference between a data warehouse and a data lake, right? So one of the main key differences is one is schema on write and one is schema on read, which means in the old days when we wrote data to data warehouse, we had to ahead of time know the schema of the data that's being stored, and if there's any ETL that had to be done so that the data is modified to that schema, we had to do it ahead of time so that it's done before writing. And whenever there's a change in the data, we had to stop, change the schema of the tables in the data warehouse, and then write it. So that's basically what schema on write means. Now, data lake is schema on read, which means without worrying about the schema of the data coming in, without worrying about doing any changes, you can first dump that data into the data lake, because the data lake can take any kind of data, doesn't have to be a particular schema. You then go in, take a particular piece of the data or set of data and say, okay, what is the schema of this set and what do I need to do to make value of this? So it's a schema on read versus schema on write. Another difference is how data warehouses only took structured data, whereas data lakes could take videos, text files, logs, JSONs, XMLs, you name it. It can take any kind of data as long as you have room for that data in your data lake. And finally, the decoupled nature of a data lake is what makes it different from a data warehouse. So back in the day, you had to maintain compute resources and storage resources available to take more and more data. So as you have more data, you had to scale up your data warehouse or have new data warehouses to be able to take that data, which means you had to have compute resources on whether the compute is going on or not, just because that data had to be stored and be readily available. Whereas in a data lake, you can decouple that and say, I can scale up or scale out my storage without worrying about my compute resources, because right now I'm only storing the data. I'm not really computing or not really processing anything. So for that reason, you can say, I'm just going to have all this data in my data lake. I'll worry about compute maybe a week from now when I'm ready to process it. And then once my process is over, I can completely shut down my compute. So you're saving a lot of money by turning off compute and only paying for storage. So let's move one level up. Once we have all the data in your data warehouse or data lake, we need something like a catalog that is cataloging all the data that's available across the board. And this is exactly the component that makes it easy for the consumers to know what's in the data lake. So on the top, we have data warehouse services, big data processing services, whether it's interactive queries or real-time queries, all these different things that the end goal is to provide business intelligence or do some machine learning on the data that's being stored. So that is the purpose of building a data lake. And if you did it on AWS, that would be a general architecture or general approach. I do want to point out that, like I said, data lake can take both relational data and non-relational data, structured data, unstructured data. And AWS does have a diverse set of analytics and machine learning tools available to read that data. Now, AWS has a service called S3, which we will talk about, is a very popular service that's used to store data. But if for any reason we have restrictions such as that data has to be within a particular VPC, it can't leave the VPC, which is a private network within your AWS account, you can also scale out your data lake into other services like Amazon EBS, which makes it possible to make sure that your data is more secure from a control perspective, from a network perimeter perspective. And of course, we want to be able to work on this data without having to move this data. So just to work on this data, we don't want to have batch jobs or transformation jobs or transfer jobs that are moving this data someplace and then processing it. No, we want to be able to process this data right where it is in the data lake. And then we want to make sure that whatever we are designing for low cost storage and analytics. Now, the question is, why use AWS for big data and analytics in particular, right? What are really the advantages of AWS when it comes to big data and analytics? Now, whether it is big data or not, AWS is very popular for its agility, which means AWS allows its customers to spin up resources or sometimes thousands of servers within a span of seconds or minutes, and run whatever innovation you're trying to do. If you're experimenting an idea, you put that in, see if it works, and then reprovision those resources whenever you're done. So you're only paying for what the amount of resources that you've used and then spinning them off or reprovisioning them. You can do the same with big data and analytics. The second reason is scalability. So we talked about how we need to be able to take as much as data as possible. So AWS has humongous amounts of resources available that you can bring as much data as you need and scale out or even scale up. So whether it's vertical scaling or horizontal scaling, there are so many options that you can do on AWS. Broadest and deepest capabilities, AWS is constantly innovating. We are always listening to our customers, taking feedback, and adding more and more features and services. As you know, if you actually just look back two or 3 years ago, where our big data and analytics portfolio was, compare that to today, we have a lot more services and features available, as you know. And I mean, if some of you have already worked with them. Low cost, AWS is always working to keep the costs low for our customers. And then providing insights and reporting on top of whatever resources we have. And finally, this is the most important advantage that we have seen with our customers. There are so many tools that AWS provides to make it easy to migrate data into the data lake on AWS. And we'll talk about some of these tools. But if you've worked with our AWS migration tools 2 or 3 years ago and compare them to today, you know we have come a long way. Okay, so putting a data lake on AWS, in the very middle is your storage layer, and that is S3, Simple Storage Service. We'll talk about that in a minute. On top of that, to ingest the data into the data lake, we have all these services that are available: Snowball, Kinesis Data Firehose, all these various tools, and we'll talk about them briefly. Once you ingest all this data, you want to be able to catalog this data or even give your users ability to search what's in that data lake. So we have services like DynamoDB, Glue, and Elasticsearch that makes it easy for your consumers to be able to search that data. Providing access and user interfaces. So we have services that make it easy in a secured way to make sure that your users are able to access the data that's available on your data lake. And talking about security, it's very important to be able to put in various security and compliance measures. So whether it is encrypting data at rest or making sure that people have, whoever is accessing only has access to what they need to access with tools like IAM, and also auditing. So CloudTrail is a great tool to make sure that everything that your users are doing with respect to API calls and stuff is always audited. And last but not least, various services that consumers can use to take this data, run analytics on it, and also serve that data to any other their end users. Okay, so we have looked at so many services, but today our main topic is serverless data lake. So sticking to serverless and data lake, these are the 4 services we are going to focus on today: Amazon S3, AWS Glue, AWS Lambda, and CloudWatch Events. So S3, we already talked about it, and I'll talk a little bit more about it soon. It's a storage place where you store all your data. AWS Glue is a serverless ETL service from AWS. So that's a service that can allow you to catalog all the data, do any ETL that you need to do, so that you can transform the data from one form to another that can be consumable to your users. AWS Lambda is a serverless function as a service feature that Amazon AWS offers. So you can write functions in the cloud and store these as Lambda functions. And we'll talk about how you can use these functions for your data lake pretty soon. And finally, CloudWatch Events. So if something happens in your data lake, which means, let's say, an ETL job is done, and in your pipeline, there is the next step that needs to happen as soon as that job is done. You can use CloudWatch Events, which make it happen where as soon as that event is triggered, they inform or trigger the next step in your pipeline. So these are the 4 services we will be focusing on today. So let's start with Amazon S3. We believe that Amazon S3 is the best place for data lakes. It has unmatched durability, availability, and scalability. So durability means the data is always stored in at least 2 availability zones, which means at least 2 different data centers which have their own resources. So if one goes down for whatever reason, the other, or if one gets lost for whatever reason, the data is always, a copy is always available in another place. So it's durable by that. And from an availability perspective, we have 11 nines availability. So that whenever you need access to that data, it's always there. And from a scalability perspective, you can add virtually unlimited amount of data to your data lake. So you can keep adding data to it, and you will be charged by how much data you're storing and how frequently you're accessing that data, rather than just servers. So this is truly a serverless service, and it has several security, compliance, and audit capabilities. Object level control, so you can actually put in a control that is at the object level, which in other language you can just say at the file level. And you can also run business insights on top of it. And there are several ways to bring data into your S3, and that's really what we are going to look next. So you can rapidly ingest data into your data lake using all these services on the left, for example. So Kinesis Data Firehose, if you have real-time data coming from social media feeds, or clickstream data coming from your users' devices, or logs coming from your applications or sensors or IoTs, you can quickly ingest those using service like Kinesis Data Firehose that lets you write into your data lake. If you have on-prem databases or even databases on AWS Cloud, you can use services like AWS DMS, which is a database migration service that can take data from all these sources, whether it's Oracle or MongoDB or SQL Server, etc., and move that into your data lake. There's a service called Storage Gateway, which means, let's say your applications are running on-prem, but you want to use AWS as your storage platform or your storage location. You can do that using Storage Gateway. And if you have offline data, which means if you need offline data transfer, which means you have tons of data and you don't really have enough connectivity with AWS locations, so you'd rather first copy that into a device and then ship that offline. We have something called Snowball Edge, and you can use that to move data from your on-prem to your data lake on S3. And finally, if you have data lakes on your on-prem and you have data lakes you're trying to build a data lake on AWS and you want to just move the data, you can also have a reliable connection rather than relying on the public internet. with Direct Connect. And with Direct Connect, you have a much more stable and reliable connection. And depending on the speed you choose at the time of setting up your connection, you can ensure that that bandwidth is always available specifically for you. Now, having talked about these services, we have 2 new services that actually launched in the last 2 years, and they have become very popular now. One of the services is AWS Transfer for SFTP. So if any of you have previously worked with SFTP, you know how used to we are, where we can just simply SFTP a file into a remote location. And we've listened to our customers, and we now have a service that you can use to simply SFTP your files into an S3 location from your on-prem. And this is fully managed in AWS and serverless in nature, which means you pay by how much data is being transferred rather than how many SFTP servers you have. And it also has native integration with other AWS services if you need to, if it needs to talk to IAM or if it needs to talk to S3, things like that. And of course, since it's serverless, it's cost effective and simple to use. The other service I wanted to talk about today is Data Sync, AWS Data Sync, which is if you have files that are on-prem and you want to make sure that that file storage or file location is always in sync with your data lake or part of your data lake on AWS, you can use Data Sync and make sure that both are always in sync. So if a file gets written to your on-prem, that file is transferred and copied to your S3 location. And if a file is added to your S3, that file is always copied to your on-prem so that they're both always in sync. And this is also a serverless feature. So you pay as you go by how much data is being transferred and stored. Now, we talked about how to bring data in. We talked about where to put the data, but I think it's also very important to talk about the right data formats. So obviously, there is no one silver bullet that says this is the best format for every use case. It totally depends on what is your workload, what are the tools you're using, what is your use case. So generally speaking, using CSV or tab separated values or JSON, they're easy because they're human readable and they can be easily maintained, but they're not efficient. So you have to either compress them and store or archive them as raw input. Otherwise, they'll be taking up a lot of space. However, since you're building this data lake for mostly machines so that the machines can go in and process the data, you can also store this data as columnar compressed data, which is, for example, Parquet or ORC. It has a much smaller storage footprint, which means lower cost for you. And also, it's much more efficient to scan and query. So if you actually need to run queries that are columnar in nature, it doesn't have to open the whole file. It only needs to read the bits that are related to that column. In the same way, you can also do row-oriented storage, which is Avro, which is also very good for full data scans. So it all depends on what you're trying to do. Now, regardless of what format you choose, it's always recommended that you divide your data lake into partitions. So if you have daily feeds coming in and you dump everything into a location in data lake, pretty soon it's going to be super big. And if you need to run queries on that, you want to make sure that if, for example, somebody wants to only look at August 19th, which is today, you want to make sure that they only need to go to a particular set of or particular fraction of data, and they don't have to scan the entire data set because that won't be efficient. So it's very important right from the beginning that we organize into partitions. And over time, you can also bring all those partitions together so that they are you can make sure that it's more efficient since you don't really need those partitions anymore. Okay. Now let's move to the next service, which is AWS Glue, and we'll talk about how AWS Glue can help you do some serverless ETL. From a data preparation perspective, we found that 80% of any work on the data lake is data preparation. So we have building training sets, we have collecting data sets, we have refining algorithms, all that, but cleaning and organizing data takes up 80% of the work. So we want to make sure that we provide the best tools and most cost-effective tools to our customers. And that's why we have AWS Glue. AWS Glue is a serverless ETL service that we provide to our customers. And these ETL services can be run on, basically they're pretty similar to Apache Spark behind the scenes, and you only pay for the resources or that your jobs are using. But most importantly, AWS Glue has something called a Glue data catalog, which is where you catalog all the data. So if you see the diagram, let's say all your data is on the left, in whether it's in Redshift or S3 or RDS, or even databases running on EC2. AWS Glue can go in and crawl all that data, scan it, and write metadata about those sources to your data catalog and keep information about that in your data catalog. And AWS Glue also has something called ETL jobs, which then use the metadata in the catalog, and then based on that, run further transformations. And whenever you have services that are ready to consume data from your data lake, they can then use the Glue data catalog to quickly understand what data they need and where do they need to go, things like that. So this diagram shows a much clearer, a better picture about how AWS Glue can provide you all the value. So it mainly has 3 components. So let's say all the data comes into Amazon S3 as a raw data. The first thing that you need is a data catalog that you set up on the top, as you can see. Then Glue comes with something called crawlers. These crawlers scan the data, get all the metadata that they need, and write it to the data catalog on the top. Then you have Glue ETL jobs that can transform this into different stages. So a typical data lake contains 3 stages. One is the raw stage. The second is staging zone, or it's also called silver zone. And then the third one is process zone, or also called the gold zone. And these ETL jobs would be responsible to transform or normalize all that data so that the consumers, regardless of where the data is coming from, or regardless of what the format is of the data coming from, or the raw data is in, they always see the process data in one form that they can easily query. So in all 3 stages, you can use crawlers to crawl the output or crawl the final data set and then write metadata about it into the Glue data catalog. So AWS Glue mainly has 3 components: the data catalog, job authoring, and job execution. The data catalog is mainly a Hive metastore, which is compatible with your typical Hive store. It contains of these crawlers that I just talked about that automatically extract metadata, and it can be easily integrated with services like Athena or Amazon Redshift Spectrum, which are services that consumers can use to easily read data from data lake and run queries and things like that. The 2 other components in Glue are job authoring and execution. So job authoring is where you actually write the code for these jobs. So it can auto-generate ETL code for you. And if that's not enough for you, you can use open frameworks like Python and Spark and write the code yourself, do some editing, debugging. And it also has something called Glue Dev endpoints, where you can actually connect your IDE to Glue and debug the code or test the code that you've written. And we'll talk about that soon. And finally, execution. So running these jobs in a serverless fashion, making sure that the flexibility is there when it comes to scheduling and handling any kind of dependency resolution, things like that. So from a catalog perspective, like I said, this is nothing but a Hive metastore, a modified Hive metastore that is managed by AWS. You can access it through a Hive metastore API, and it's also supported by tools like Hive, Presto, Spark, etc. It gives you features that you can use to search, or it even provides a connection info like JDBC URL, so you can use a tool external tool that can query, that can connect to the data catalog and do some queries. And you can also do classification based on, so we talked about partitioning. So if you already have partition done, it can quickly classify data based on those partitions. And finally, versioning. So if it sees that the schema of data has changed over time, it can maintain all those versions of metadata so that you know the life cycle of how exactly the data has transformed over the years. We talked about crawlers. So this is something that goes into your data, scans the data, discovers it, and extracts the schema definitions. They can even understand partitions, and you can also use built-in classifiers. So you can use CSV classifiers, you can use JSON classifiers, and you can also build custom classifiers. And you can run these crawlers either ad hoc, which means on demand, or on a particular schedule, and pay only whenever these crawlers run. So we talked about partitions, right? Here's an example that I actually gave you. So when you're storing files in S3, if you can store them in particular folders, so a root folder that contains the months, and then subfolders that contains the date, and then files within that, as you can see, Glue then sees that structure, and when it's writing all that information to its own table definitions on the right, it writes that information and say, okay, we have month, we have date, and then these are the columns in the files. So when you need to query the data, or you can just go to this table and say, give me the data that matches August 19th, it right away knows that these are the list of files, or these are the files that I need to scan. I don't need to scan all the files. And that's the power of partitions and Glue Data Catalog's ability to detect these partitions and store the partition definitions in its tables. So here's a typical example where after the scanning is done, if you look at all the details, so it keeps information about what's the name of the table, basic description, what is the location of the files, and then some statistics and the schema of the table. And on the bottom right, you can see a screenshot of so there's a struct. So if you expand the struct, you can see what are the fields within that struct. So this is a JSON file that got scanned, and these are the files that it detected. Okay, so the second component of AWS Glue is authoring. So as we talked about, AWS Glue can auto-generate code, especially if you're a newbie and you just want to use some basic ETL functionality within Glue. It's really intuitive. You can go in and drag and drop stuff, and it writes the code for you, especially if it's straightforward ETL. You can also connect a notebook like Jupyter Notebook or your IDE to AWS Glue through something called AWS Glue Dev Endpoints. And then whatever code you're writing on your computer, you can actually execute it on Glue and see the results. And if you already have code that's written in Python or your local data lakes, you can also bring that in. And if it's compatible code like that's using Spark and stuff, very little modification is required, and it can be run on Glue as well. So here's a screenshot of automatic code generation on the left. As you can see, you can drag and drop the fields that you need, the conversion that you need, and then on the very right, you can see that the code is being auto-generated. So this is very helpful for newbies who just want to get their hands wet with Glue. And the code that's generated is human readable. You can go in and edit it, or even port some PySpark code into it. It's flexible, so it uses ETL libraries wherever possible, so that when it comes to manipulating complex or semi-structured data, you don't have to write the code, or it doesn't generate the code every time. It uses well-tested libraries there. And it's also customizable, which means you can go in, bring in custom libraries, or leverage AWS Glue's libraries, or even use native PySpark. And it's collaborative, which means you can share these snippets on GitHub and see what the community says about it, or get some thoughts about your code. AWS Glue also has something called dynamic frames. So it's pretty similar to Spark's data frames if you've already previously worked on Spark. but they're better when it comes to cleaning and restructuring semi-structured data sets. So if it's JSON or Apache logs, the dynamic frames that come with Glue are really powerful. And there's no upfront schema needed, so it infers the schema on the fly. And in a single pass, it enables you to transform this data. And whatever is unexpected, it can easily handle that. So it can track new fields, any inconsistent changes of types with choices. So for example, on the previous read, it was a string, and now it's an integer. It can easily detect that. And it automatically marks and separates error records. So that's another thing. Sometimes you run into these errors. So you want to make sure that the code can handle all that. And dynamic frames are really powerful when it comes to that. And finally, when it comes to authoring, like I said, there's so many samples that are available. So if you go to that link to our GitHub location, you can find migration scripts. You can use Glue's ETL jobs or ETL scripts to migrate data from your on-prem into S3, do some modifications on the fly, and write them. You can also use something called relationalize. You can see examples of that here. So let's say you have a JSON file and you want to convert that into a relational table. There is a transform that's available with AWS Glue that's called relationalize, where you can just input that JSON file and it will relationalize for you and store it in the form of tabular data. So that's another way of really getting your hands dirty with AWS Glue or Glue ETL. Now, the third part of AWS Glue is the actual execution. So when it comes to scheduling and monitoring, we want to be able to trigger these jobs either on a schedule base. So you can just configure some cron times and say, run this every hour or every 3 hours or every 6 hours. Or it can be event-based, which means if one job is complete, that's when I want this particular job to trigger, and so on. So you can see on the right, there is a pipeline, and it's either schedule-based or event-based, or you can even do it on demand, which means you can write a Lambda function that then triggers a Glue ETL job. And we will look at that architecture a little later, but you can use that as well to trigger these ETL jobs. And finally, you can set up S3 notifications. So as soon as there's a new file or a CloudWatch event that says, as soon as a crawler is done or as soon as a job is done, you trigger the next step. So all this can be done with AWS Glue ETL jobs. And finally, all the logs of what's happening in the jobs and the alerts that you need are available in a service called AWS or Amazon CloudWatch, which gives access to anything that you need to do when it comes to monitoring these jobs. And last but not least, why we are here, to make sure whatever we're building is serverless. So AWS Glue, it automatically provisions, configures, and manages services. If it needs to be in a VPC, it automatically makes sure that that particular job is in a particular VPC. It doesn't touch any of your other VPCs. It can automatically scale resources. So if a particular ETL job needs more resources than another one, it can automatically scale it. And finally, you only pay for what you use. So serverless. Okay, let's talk about some of the common use cases. So here are some logs coming into an S3 bucket on the left. You use AWS Glue crawler to crawl all that information, get the metadata, and then you use Glue ETL to maybe convert that into partitions and write into a separate bucket or a separate location in S3. And then use the information in the catalog. So Amazon Athena on the very right is first going to the catalog, getting some metadata about the information, and then querying the second S3 bucket to understand to be able to get that data using simple queries. Here's another example where the data is real-time in nature. You're using Kinesis to bring all the data in, write it to S3. Then, similar to what we did in the previous slide, use glue crawlers to store all that metadata, and then Athena is using that metadata to query the final bucket. If you have data on-prem, and let's say they are all on your local databases in your data centers, you can use something called AWS Glue JDBC connectors to connect to those databases. Write AWS Glue ETL jobs that go to those databases, get all the data, and either save them in RDS or save them in Redshift or save them in S3. And let's say we saved them in S3, then you would use crawlers to crawl that data, store metadata in your data catalog, and finally use Athena to query that data. So these are some of the common use cases that you see with AWS Glue. So now let's talk about the third service that we are here to talk about, which is Lambda, which is another serverless service, which is basically a service that allows you to run your code as functions in the cloud. So without worrying about infrastructure that you need to manage or any kinds of how many servers you need, things like that, you just focus on the business logic and you write these functions. And it's cost effective and efficient because you only pay again for what you use rather than how many servers you're running. And it can be run in many languages, many of the standard languages. So typical serverless application, you have a source that triggers your function. You have the actual function in the middle, either written in Node or Python or Java or .NET. We have a long list of languages that we support. And then finally that code does something. And that something could be writing to database, reading from database, calling another API, things like that. Now in the left, there could be so many sources, right? So they can be a change in database. So something got written to DynamoDB and that's triggering a Lambda function, or something, a new file came into S3 and that's triggering a Lambda function, or somebody made an API call and that API call is triggering a Lambda function. So there could be a long list of sources. And here's some more examples. So you have data stores where data is coming in and that's triggering a Lambda function. So we recently added RDS Aurora as one of the triggers. Oops, sorry. And Alexa, if some of you have used Alexa, it's calling Lambda in the background. So as soon as it gets instructions from you, it's calling Lambda to execute that instruction. In the same way, we have repositories, message services, or even state management or orchestration services like AWS step functions. For some reason, my slide is automatically moving to the next. So we have various ways of triggering these Lambda functions. Here's a use case that you can use for our data lake pipeline. So let's say we get data from your devices, and the data is being written in real time to data firehose. And the data firehose, what it does is takes all that data and is supposed to package it and write to S3. But before writing there, let's say you want to do some transformation. So you can connect that firehose to Lambda on the top and say, hey, take these raw records, transform them, use some lookup tables in DynamoDB, and then give me the transformed records. And so that's exactly what Lambda can do. It can take that raw record, transform it, and then Firehose would write those transformed records to S3. Here's another example where a streaming source sends all the information to Kinesis stream, and the Kinesis stream then invokes a Lambda processor function, which processes that data, and it can do whatever the code says. So it could integrate with other AWS services. It could even write to another function. It can do anything, like whatever you want the code to do. Okay, and when it comes to invocations, it's all automatically handled. So if you have multiple streams coming in for the same exact source or for the same exact Kinesis stream, let's say multiple sources coming into multiple shards, Lambda automatically can concurrently be provisioned. So all of those are processed in parallel rather than in serial. Okay, now let's look at example architecture. So here we have a raw bucket on the very left, files coming into that raw bucket. As soon as a file comes into that raw bucket, that triggers a Lambda function. Now the Lambda function can either right away call a glue crawler, or if something goes wrong, it can write that to a retry queue. And that retry queue can be checked at a later time to see if there's anything that got missed. But let's say everything goes well and it triggers a glue crawler, and glue crawler then scans that raw data that just came in. And once the crawler is done, it invokes a CloudWatch rule, because the CloudWatch rule will get fired saying, okay, the glue crawler is done. So now I have to trigger a Lambda function. The second Lambda function that you see here, that would be responsible to trigger an ETL job that you've configured in AWS Glue. And that AWS Glue ETL job will go to the raw bucket, take the data, transform it, process it, and write to a processed bucket. And once that job is done, we have another CloudWatch rule that as soon as the job is done, it gets triggered and sends an email notification. So this is an example architecture, completely serverless from left to right. There are no non-serverless resources that are used here. So you're only paying for whenever there is a file that comes in and when that file is getting processed. So here are the steps that I just talked about. So ingesting the data, configuring the trigger, then automating the catalog, authoring the jobs, and finally monitoring the CloudWatch events. If you want to try what I just talked about, you can actually go to this link, and I'll share these slides with you. You can go to this link, which has a blog that has a CloudFormation template that can set up that architecture for you. And all you have to do is follow these instructions and learn, try to get your hands dirty a little bit with how exactly a serverless data lake works. So you can work with S3 triggers, Lambda functions, glue crawlers, glue catalog, glue ETL jobs, and finally email notifications. So this blog can actually help you self-learn an application like that. Now, I talked about how popular data lakes are becoming on AWS. We believe there are at least more than 10,000 data lakes that are currently being built and maintained on AWS. You see all these logos that currently use AWS for their data lakes. And we have several partners who can help you build these data lakes for you. And then I appreciate your time. I know we have about 7 minutes left. So do we have any questions? Let me see if there's any.
I believe all the questions were answered instantly in the chat.
Oh, awesome.
So they're all over it, which is fantastic.
Awesome.
Addy, you came prepared?
Yeah, we have the best. We have the best. So I see we have 49 attendees today, so that's great.
You know, I had a question I was going to toss out there, but then you popped up, and my question was going to be around how, you know, whenever you see a presentation or hear someone speak, they'll talk about sort of the data cleaning piece almost as if it's trivial. And so my question was going to be, you know, maybe you can tell us more about that. But then you brought up your slide and you said, hey, look, it's a big chunk of this that's about cleaning the data. I thought that was really interesting.
Oh, awesome.
Curious to hear from you, you know, just a running thought from that is, you know, do you find that folks understand the investment there? Like, you know, so we can say, hey, you know, we want to go serverless, we want to do this. What are those conversations like in terms of understanding the investment that has to go into it?
It depends customer to customer, but most of our customers, like when we build a POC for them and show what is involved when it comes to bringing data in and how quickly they can use these services from AWS to get the end results and compare them to what goes currently on-prem or in their manual process that they have. The numbers speak for themselves, right? So that's probably the best way to show the difference, as to show the value in building a serverless data lake. And of course, costs. That's like when you first get started, you don't want to spend too much money spinning up resources, whether you want them or not. So starting serverless, and maybe if you get to a point where processing the data, it makes sense. It's so often, or so we are at a point where it makes sense to spin up an EMR cluster, or we are at a point where it makes sense to move some of this data to Redshift. Only then consider a non-serverless approach. But until then, we don't need any of these non-serverless resources. We can, if we make them show the difference, like using numbers and using like a POC, that usually makes a big difference.
No, it's super helpful. Thank you for sharing that. And thank you again for the time today. You know, this is, we had a really great group today. Just want to give a shout out to Adi for joining us, and also to the Innov8 team, Carol, Aaron, just going down the line. We had a great turnout today, folks. Really glad that you made time. Thank you so much for joining. Aaron, I just want to kick
Timothy,
it over.
if you don't mind, I also want to extend the thanks to the folks who answered all the questions. So I'm not exactly sure who answered all the questions, but whoever did, thank you so much. Appreciate it. Thanks for the support.
No, definitely. It was pretty spot on. So Aaron, I don't know if we have any closing announcements or anything, but I think we're good here. This is fantastic.
So that's my email address. If you have any questions regarding the presentation, or something in the presentation that interested you, or if you have any questions, please reach out and I'll be happy to respond with my answers.
Eddie, are you sharing the slide? Are we able to share the slides out as well? It looks like there's a question from Roger Davies asking that very question.
Yes, I will convert. I will send these to Erin or Carol, and hopefully they can share. Right?
Absolutely.
All right.
Thank you so much. Kicking it over to you, Aaron, to close us out.
I don't have anything other than everyone keep an eye in your mailbox for the next Innov8 that'll happen in September. We always email it out. We always let you guys know that it's coming. Thanks for coming, everybody.
Thanks, everyone.
Thank you so much for your time. Appreciate it.
Thank you, Addie.
Thanks, Addie.